Hello, hello. Welcome to today's webinar. So we are going to talk about the right way to integrate Octopus Deploy with Azure pipelines, and this is a very, very popular topic. We've had a lot of people requesting it, and we have just a massive number of people here. We're going to try to get to all the questions and work them in, and so there is a Q&A window that you can ask questions to during the webinar. And I'm pretty good about getting in the questions as we're going through the topic, but I will commit to you that if there's questions that have been unanswered that I haven't worked in, then I'll stay on and answer those questions directly. And I'll also give you my email address so that you can email me questions after this is over, and I love getting those emails. So Octopus Deploy is the first and the most mature product for automated deployments on the Microsoft platform. Azure Pipelines has made a lot of headway in the environment management space, but Octopus Deploy has been doing it for a really long time. And so there's a lot more features and functionality, especially for the sophisticated and the more complex scenarios that you might have to handle. And whether you're a current user of Octopus Deploy or whether you're just merely looking forward to DevOps automation at your company, you need a streamlined DevOps architecture for promotion across your pre-production environments and your production environments. And you need to limit who can deploy to production. You need to ensure releases have been tested first, and of course block promotion of broken releases. And many teams ask common questions about how to structure deployable application components and how the deployment fits in with other elements in the DevOps pipeline, and I hope to answer a lot of those here. So we are going to cover today a complete DevOps pipeline that integrates Octopus Deploy with Azure DevOps services. We're going to talk about how to structure all the way back to the beginning of your Git repository, your version control system, and how it can have a profound impact on how easy it is to deploy your code. And other key elements of the environment that we'll go through is the continuous integration build, because that also affects the deployment structure. And there are some rules of thumb that when you follow them, they make the structure of the automated DevOps environment fall into place nicely, very nicely. And if you aren't aware of these rules, or if you break them, whether intentionally or just making a rookie mistake, then you'll continually struggle to achieve that no touch, no drama software deployment that we all want. So in this quick webinar, we're going to try to get you in and out in just over 30 minutes. You can be well on your way toward stress-free software deployments using Octopus Deploy and Azure pipelines together. Now, although this is an architecture, some of the assumptions is that we are on Microsoft platform. Okay, and by way of introduction, I am Jeffrey Palermo, your host, and also the chief architect for ClearMeasure, and we are a software architecture firm that specializes in Microsoft and cloud software. And whether it's companies that do development in-house, or whether it is contract development companies that do outsourced projects, those are the type of companies that tend to use us to help up-level their team, help their development teams move faster, increase quality, and run their systems with confidence. Our goal for you, regardless of what type of development team you oversee or participate in, our goal for you is for your team to be able to deliver world-class results. And we like to see those capabilities increase. So let's get on with the content. Okay, so our webinar is structured like this, and we're gonna talk about some of the objectives that we're all going after, how architecture fits into DevOps, the 7 different parts of the pipeline, and how Octopus influences all those different parts. And then we'll talk in detail about integrating and how the parts of Octopus integrate with Azure pipelines and what it looks like. All right. So I want to give you something of value and help you get automated. Um, I know everybody's coming to this webinar from a different place, but I don't want you to continue to not make traction and be stuck getting DevOps capabilities deployed for your team. And you know, a lot of people tell us they sometimes feel trapped by the software that they work on because the software always seems to find a way to break upon deployment. And sometimes it translates into lost weekends or surprised overtime when the builds and deployments go poorly. And here at ClearMeasure, we've helped thousands upon thousands of professionals across over 40 countries be better at software. And my latest book, .NET DevOps for Azure, really exposes the secret about how any team can have a fully automated DevOps pipeline just by following a concrete 7-stage design. And so here's what I'd like you to do. I'd like you to read my book. Just for being here on the webinar, I'll give you a free chapter. We have a subset with some select chapters just for being here on the webinar. So just send me an email, or you can follow the instructions in the chat. My webinar assistant Heather is going to help with that. And second, understand those 7 stages of a DevOps pipeline. It's in the book. It's not rocket science. You just need to understand those 7 stages. And then third, launch your own .NET DevOps pipeline. Just start putting it together. Use the public project that's in the book as a model. And although this does have examples in Azure, if you are virtual machine based, then all of the principles translate right over. And you know, if you do this, you're going to have a fully automated DevOps pipeline that'll enable you to move faster with higher quality. Also, another resource you might be interested in is the Azure DevOps podcast. And we interview people from Microsoft, from other relevant product vendors, and people from regular companies that are sharing their success story. And it's a weekly podcast. It's in all the podcast directories. You can just queue it up on your smartphone, listen to it on your commute or while mowing the lawn, whatever suits you, if you're a podcast listener. Also, from a skills development perspective, we are in the process of scheduling our next quarterly .NET DevOps Bootcamp. And we launched this new training series last year, and it's been tremendously successful. It's the next class is going to be in April, and it is in Austin, Texas. So if you would like to visit sunny Austin, Texas in April in the spring, we'll be very near the lake. And so you just look for the exact dates, or just send me an email if you're interested, and we can get you signed up for the class. And we do have discounts available for multiple people from the same team. All right. From an Octopus Deploy perspective, there's lots of topics. I wanted to highlight one of them that I've done in the past. We've done a joint webinar with Paul Stovall, who's the founder and CEO of Octopus Deploy, specifically on database DevOps and how to automate the database portions of a DevOps environment when you're using Octopus Deploy. And so that webinar recording is available. You can go to bit.ly/Octopus Database to find that recording of that joint webinar that we did. We're not going to go tremendously in depth about the database or any particular application component type here. We're talking about the architecture and the structure as you put this together, but that is so common, and the database is sometimes such a unique challenge that I just wanted to provide that resource for you. All right, so let's get into the objective that we're going at here. Now, just judging from the job titles in the group that's here on this webinar, we know that you are a leader, and as the leader, you have to come up with the direction and guide the organization down the right path. With the right strategy, things are going to fall into place pretty nicely. But with the wrong strategy, there's no level of execution that can make it great. And architecture is a special type of strategy. And there's three types of when it comes to architecture. The first is the design of the software system. And the second is the design of the organization that builds, changes, or maintains the system. And the third is meeting budget and schedule targets and orchestrating constraints and sometimes modifying trade-offs in order to meet those constraints, those targets. And DevOps helps give us a model to ensure that we identify all of the needed architectural elements as we put together these three architecture types. So DevOps, if you haven't heard DevOps defined before, there's three overarching principles. The first is flow, the second is feedback, and the third is continuous learning. Flow is the process of smoothly going from thinking about an idea or a change to the software and getting it into production in the hands of the users. Feedback is all of the quality control checkpoints that we put at every stage of our pipeline. And then continuous learning is looping back from the people using our environments, our customers, all the way back to decisions about what to change next. And I want to give the analogy of the DevOps pipeline in the terms of water, because that is a really good analogy that colors everything. If you think of the pipeline as a smooth flow of water, we don't want tidal waves coming down the pipeline. We want a smooth flow of water. And the feedback is implemented as filters that are put every stage of that pipeline so that the impurities of the water are caught and don't flow onto our customers. In addition, the water comes from somewhere, and we'll talk about that, and it goes to our customers, okay? And then that set of filters, those are the quality control checkpoints, making sure that the impurities are caught so that finally we have nice, pure, clean water being delivered to the customers. Beautiful, well-operating software features being delivered to our customers. All right, so let's talk about DevOps and architecture. It can be easy to think of just the second type of architecture, essentially the design of the application, as everything. It's really important, but the DevOps environment itself is a system. It's an organizational system of taking all of your people and organizing them into essentially your virtual manufacturing plant that produces software features. And so design this system, not just the .NET application that may be a ASP.NET with some APIs, with some backend jobs, with a SQL Server database, or a Windows app or a smartphone app. I mean, all that's great, but how the team itself operates, that is a system of itself, and that will produce any number of applications. All right, now we talked about the DevOps pipeline, and that is a central capability. But you also need to think about the organization's capabilities in 5 other factors: what practices you're going to use, how you're going to find and remove defects, what the overall team workflow is going to be, the sequence of steps and who's doing what, the blueprints for the application that you're actually building, and then how you're going to operate the application, cloud operations. And in DevOps, there are 7 recognized activities, and some people call them different things, but they are plan, code, integrate, package, release, operate, and learn. And for all of these capabilities and for each part of the process, you need to have a sound strategy. You need to execute that strategy in a disciplined way, and then measure so that you can know that the strategy is working. Now, before we go into Octopus Deploy, I want to give you the overview. This is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy. It has a continuous integration build and a 3-tier deployment pipeline. I want each of you to have this. So we're going to be posting a download link in the chat. And this is just the top 1/3 of the architecture poster. You can print it out at your local print shop, and it's it's the overall architecture of what you're going to implement. Actually, it's useful even if you were not using Octopus Deploy, or even if you were using a different build server other than Azure Pipelines. But we're going to go through each of these major stages, and I'm going to walk through how each of them must be done right in order for you to have success with an Octopus Deploy implementation. All right. This is a picture of the entire poster. Obviously, you can't read the words, but if you request the poster, you can have that. We're working jointly with Octopus Deploy, and we have a redesigned poster that uses a dark theme, since dark themes are all the rage. And so we're going to be, hopefully we'll have that available soon. Now, the 7 key elements that we need to think about from a high level: the process before we write any code, the structure of our version control system, how we execute builds, how we do full system testing, how we do manual testing or user experience testing, and then the production release, and how we watch the system, which is telemetry observation. Those are the 7. So let's just go through here. We're going to blaze through the pre-code design process because we need to get into the Octopus Deploy integration. But if you don't make those 4 types of design decisions before we write code, then we're just essentially sending out dirty water down the pipeline. So I've gone into depth in some other details, but in some other webinars on the pre-code design process, but I'm going to fast forward a little bit to the source control area. But I'll give you a teaser. In your Kanban board, you're going to have these 4. Essentially decisions that you have to make. Okay. All right. Let's go on to the next. All right, now we're on the version control system. Now, this is very important. The version control system, the Git repository, is the headwaters of the DevOps pipeline. It is where everything starts. And if you start with some wrong assumptions, then nothing downstream is going to work properly for you. So the key rule of thumb is 1 application per Git repository. We are going to build 1 application. We're going to package it up into a set of release candidate packages. Each package is going to be a deployable process. For instance, we're going to have a package for the database, a package for, say, if you have a web application, a package for an offline job, a Windows service, or an Azure function. But you're going to have 1 release candidate that is made up of a set of deployable NuGet packages, and that all comes from 1 Git repository that likely has 1 Visual Studio solution. So that is the rule of thumb. If you have a big software system decomposed into multiple applications, that's great. Each of the applications need their own Git repository, and then we'll configure a pipeline specifically starting from that Git repository. So that is very, very important. Okay, now let's talk about the build. And you can see the little octopus icon. We're annotating that for where you have to do something specific for integrating with Octopus Deploy. A build is essentially a test. So you've heard of arrange, act, assert. That is a part of test-driven development. If you haven't read the book by Kent Beck on test-driven development, I'd highly recommend that you read that. But arrange is setting up the environment, getting ready to go. We need to create our database locally as part of the setting up of the environment. The compile is the act of translating source code files into executable intermediate language or DLL files. And then we run our tests. Static code analysis probably starts off not being an assert, but it could move over to assert once you mature in that area. And then we need to package up all of the different deployable components of our application in NuGet files that Octopus Deploy can understand. And so to do that, we integrate Octopack, which is octo.exe, in with our build at the end of our build process. And after doing a .NET publish, we then run octo.exe on the directory that we did a publish. and it essentially zips up all those files. Now, if you're on .NET Framework, then you can integrate Octopack directly as a NuGet package into the projects themselves, and then you don't even have a command line. It's just automatically done. But you need to integrate the Octopack tool in with your integration build to produce the deployable packages. All right. Now you need to think about where you're going to be deploying. You have a whole spectrum. You could deploy to physical servers in an on-premise data center, or you could deploy to platform as a service resources in Azure, or right in the middle, you could deploy to VMs. There is a spectrum where on the left, you have more control, but you also have more responsibility. On the right, you have less control, but you have less responsibility, less to maintain. And so that's the spectrum of choices, but Octopus Deploy can deploy to any of them. But the packaging needs to have some knowledge of how they're being deployed. All right, we are going to have to make a decision for where to store the release candidate packages. Now there's two choices. One is the NuGet server directly in Octopus Deploy, and the other is the NuGet server that's run in the Azure Artifacts product that's a part of Azure DevOps Services. Now, I'm going to recommend that you store them in Azure Artifacts, and that is because Octopus Deploy is not a build server. Octopus Deploy is a deployment server, and the deployments are going to be absolutely streamlined. They just fall into place like butter. And so the limitation is that external NuGet clients cannot connect to the NuGet server inside Octopus. Only Octopus can get to the NuGet server in Octopus. So I'm going to talk about full system testing and deployed test suites here in a minute. In order to get access to the right version of the full system acceptance test suite, we need it in a NuGet server that's accessible from our build server, which is Azure Pipelines. And so at least that needs to be in Azure Artifacts, because once we put a deployable package into Octopus's NuGet server, we can't get it out from anywhere except within a NuGet project. So therefore, if you're using Azure Pipelines as your build server, I recommend using Azure Artifacts for your release candidate store. All right, don't use the old build artifacts with the drop convention, because then when you clean up your build history, those two concepts are tied together. All right. Now let's talk about how Octopus interfaces with the different environments. There are 3 unique types of environment. Everybody knows production. You need at least one of those. And pulling back from production, everyone knows the manual test environment. You need at least one of those. There's plenty of names for them: dev, test, QA, sit, dit, staging, UAT. There's all kinds of names for environments where someone manually verifies something and manually tests something. But you need at least one of those. You can have as many as you like, but you need at least one. The third unique type of environment is the test automation environment. We call that TDD, to invoke test-driven development. But it is the test automation environment, completely automated. No humans are allowed on this environment. If a human was to try to use it, the application would be ripped right out from under them, because it's constantly deploying the next version, running the full system tests and any other deployed test suites that you have, and then throwing that installation away and putting the next one down. But those are the 3 unique types of environments, and you need at least one of each. Okay. Now, the sequence, we're going to talk about the sequence of deploying to these. Azure Pipelines is your orchestrator. Okay. It's the orchestrator of the main path, and we're going to go through that next. But Azure Pipelines is going to delegate deployment to Octopus Deploy. Then when Octopus Deploy is finished, control will return to Azure Pipelines for the execution of the tests against that fully deployed environment and any built-in system health checks, approvers, or whatnot. Okay. So this is what Azure Pipelines looks like, and it's straight through one environment per type, TDD, UAT, production, and that's what the view would look like in its most basic form. You'll never have a pipeline that is shorter than this because you need at least one of each of the three unique types. Now, there's two integration strategies with Octopus Deploy. The first one is fire and forget, where you don't even have a pipeline in the release configuration of Azure DevOps. You just have an integration build, and then you use the Octopus Deploy task to create release, and then you promote from environment to environment over in the Octopus Deploy dashboard. That's the first one. If you do that strategy, then all the people involved will have to have Octopus Deploy accounts, including approvers. And so if you want to have some stakeholders be able to hit an approve button, and they'll have to have an Octopus Deploy account as well. The second integration strategy is the orchestrated strategy. And that is where you map all of the environments like you see here on the screen and let Azure Pipelines be the orchestrator, but Octopus Deploy does the deployment part. The advantage to that is that you can have approvers who are non-developer stakeholders, and they can approve deployment to production without having any Octopus Deploy direct access. The tests can be run in Azure Pipelines after Octopus Deploy finishes a deployment, so it enables full system tests of various kinds, including functional tests, security penetration tests, screen reader compatibility tests, any kind of test suite that needs a fully deployed environment. And then finally, all of the logs of the deployment are all in one place because all the logs from Octopus are streamed up to Azure Pipelines. Now, there is a caveat. Some of the advanced Octopus Deploy scenarios have no parallel in Azure Pipelines. For example, Octopus Deploy tenants and channels, they don't even have a concept in Azure Pipelines. And we do have a question that came through in the chat. I'm glad I caught it because there was also a Q&A window, but it was hey, what can Octopus Deploy do that Azure Pipelines can't do? Well, if you have many production environments, because you deploy a production environment for each customer, that is that's the tenancy factor. Octopus Deploy handles that like a champ. There's really no concept in Azure Pipelines of tenancy. So you can't have parallel production environments. You have to manually configure those. And it is a change to your pipeline structure every time you get a new customer or every time something about the customer changes. In Octopus Deploy, it's just a variable, okay? And same thing with the manual test environment. You could have a UAT environment for multiple departments spun up automatically, and that also uses the tenancy feature. It's essentially a parallel environment feature, and that's handled natively in Octopus Deploy. In addition, channels, there's no representation of channels like hotfix or beta or alpha in Azure Pipelines, but that's a first-class citizen in Octopus Deploy. The normal day-to-day cases work fine, the happy path case, but if you're dynamically provisioning and configuring environments and destroying them and creating the parallel environments, you'll have some deployment scenarios that just have to be managed in Octopus Deploy because Azure Pipelines has no way to model those scenarios. And it can quickly get out of control if you try to model it because the modeling is very static in Azure Pipelines. All right, so here's what it looks like when you jump into one of those jobs in Azure Pipelines. The first task is to delegate to Octopus Deploy and tell it to create the release. And Octopus Deploy will create the release and automatically deploy to the first environment, which is the TDD environment. And now we have a fully deployed application. After that happens, now Azure Pipelines regains control and can do the full system test suite. So it's going to download the test suite package. It's going to push in connection string and the URL to the web server of where we just deployed to. And then we're going to run the test suite, whether it's in unit, X unit, whatever can be run with the Visual Studio Test adapter. In addition, we can add all kinds, we can push all kinds of variables to Octopus Deploy when it does its actual deployment. So we have a choice of which variables to manage in Octopus Deploy because they're environment specific, and which variables to manage in Azure Pipelines and pass them on through because maybe they're application specific or process specific. So that's how the two integrate together. We always want to tell Octopus Deploy exactly what to do, and so we want to pass the specific release number that we want deployed. And we can flow that through because we assign it in the integration build and we flow that same version all the way through. Now, for subsequent environments that don't have a test suite, you may have the case where you just have a single task that is telling Octopus Deploy to deploy downline. Now, that's possible, but it's unlikely because at least you want a smoke test or a call to the built-in health check of the application. There's two options for telling Octopus Deploy to start deployment in a downstream environment. You can use the promote task, or you can use the deploy task. I always prefer the deploy task because the promote task relies on the logic of the Octopus Deploy lifecycle to guess which environment is next and which version should be promoted. With the deploy task, we can explicitly tell it what environment to go to next and what version number to promote. It's very explicit. And then the knowledge of that and the control rests in Azure Pipelines, so you see it all in one place. Okay, when you have a variable that you want to receive an Octopus Deploy, but you want to pass it from your build server, you need to make sure to go into the advanced area of your Octopus Deploy configuration in your variables and check prompt for value. If you don't prompt for value, then it will not be accepted from the outside, even if it's passed in. It'll be assigning the value even if it's blank. So you need to make sure to check that box. That's very important if you're passing variables between your build server and Octopus Deploy. This is what the Octopus Deploy process is going to look like. It is and this is another example of what's the difference between the release manager configuration in Azure Pipelines and Octopus Deploy for the purpose of deploying application components. You see how few steps there are. It is so much simpler in Octopus Deploy from a UI configuration perspective when it gets down to complex deployments. For instance, the human approval, you can see the line through because it's disabled. If we're integrated with Octopus Deploy, we do our human approval in Azure DevOps. The next step is annotating the release, which we'll go into later, because we always want to emit some telemetry that says, hey, I'm starting to do the deployment. This application has two deployed components, a database and an ASP.NET web user interface. And therefore, there's only two steps. There's one step for the database and one step for the UI. And within the database, there's the options to do some unique things there. But there is a hierarchical organization of the process in Octopus Deploy, which I think is very useful. Whereas just in Azure Pipelines, it's a procedural sequence of tasks that don't, in an obvious way, have any relationship to each other. So, and Octopus Deploy does almost all of this automatically for you, whereas you have to do a little bit more. It's perfectly possible in Azure Pipelines for a lot of scenarios, but Octopus Deploy has such a rich and mature library that it falls into place. Now, let's talk about variable architecture, because you're going to have a lot of variables, regardless of if you choose to use Octopus Deploy or Azure Pipelines, you're going to have a lot of variables. And a variable is a piece of data. So architecturally, you need to ask who owns it. Is the system of record the build system or the deploy system or some external system where data needs to be pulled in? Use the dry principle. Don't repeat yourself. And if you don't create a strategy for configuration management, then you are really rolling the dice on a management nightmare that's going to happen pretty quick. Every system has configuration management needs. You must design it. Remember, design doesn't just happen. It has to be intentional. Now, let's talk about the full system testing step. Continuous integration, that was really defined by the Addison Wesley book that was in 2006. And if you haven't read that book, go read the book. It's literally called continuous integration. The continuous integration process starts on a developer's workstation, and it completes when we know that the change that we just made still allows the application to be stable. Now, to get the answer to that question, you need to deploy the application at least once, make sure that it starts up, and make sure that the major capabilities still continue to work, okay? So this is a big mistake in the industry. People saying, hey, we're gonna implement continuous integration, but the implementation does not include a deployment to some environment. It could even be a local deployment to the same server that's acting as the build agent or the build machine. It doesn't matter where you deploy, but we need to know the answer to the question, did what we just do cause the application to not be able to start up? And so how many times, if you have a situation where you have a compile, which is automatically triggered by a source control change, and that's called continuous integration, then you probably have a scenario where you do a deployment to a downstream environment and a showstopper bug is found right off the bat. Something's completely broken, or the application just gives the yellow screen of death or the big error screen. It's because, hey, your build succeeded, your integration build succeeded, but you had destabilized the application in some other way. So continuous integration is not complete until you've done a deployment and know that the application still starts up, okay? And this is the flow on the screen of full system testing. We specified the test scenarios before code is worked on. That's one of the 4 pre-code design decisions. Then we do the private build on the engineer workstation. We do a git commit. A lot of times this is on a feature branch. The integration build operates on the feature branch, then packages up a release candidate, does the deployment. We run the automated acceptance tests. A lot of times for web, it's Selenium. And then once we know that we're all good, we create a pull request, and then our team can execute the inspection on the changes for that pull request. So that's the cycle, and continuous integration is going to make sure that we have a very short cycle time there, and Octopus Deploy fits into the deployment part, because we're not done implementing continuous integration until we have done at least one deployment. Okay. All right, let's go into the next piece. These are the 3 Kanban columns that are affected by what I just showed you: the test design, development, and then functional validation. All right. We do have a question that I'm going to get to from Mike. And we're talking about large systems. How do you handle it when you have upwards of 40 different applications in the same system? I am going to talk about that. I want to get to a few other pieces just to show you. In the full system testing, because Azure Pipelines is executing the full system testing, we want to make it easy to see and handle triage when one of those tests breaks. So we want to make sure that we're capturing screenshot attachments when we're running the tests. So this is inside Azure Pipelines, and on the right-hand side, you can see what looks like a form, because this is the inside of a browser window, and it is the application itself with 3 text boxes and a button, and we are capturing a screenshot while the automated tests through Selenium are typing in data and hitting the save button. And every step of the way, we're doing a screen capture and creating a test attachment so that if something goes wrong, and they do, you have a very short debug or short bug reproduction cycle. All right. Now, for deploying to different environments, we want to make sure that we don't ever deploy to production some step or some activity that hasn't been done the same way multiple times before. We don't do anything new in production. We do the same thing. And there's some specific things to think about when you're choosing automated database deployment strategies, state-based versus migration-based. I'll give you a hint. Migration-based works better in a DevOps scenario. But here's just a chart of common things that you would do on the various environments. Now, let's get through telemetry real quick. We want to make sure that all of our logs are centralized and taken away from the environments. Application Insights can do that, but also many other products like Splunk or Stackify, they do that as well. Don't leave your logs on the actual environments. Get them away, get them centralized, get them aggregated. In addition, you want to have a complete telemetry story. Logs are not sufficient. You also need events. You also need metrics. We've done some other webinar topics diving deep into that. But if you need some help on that, just send me an email. You need a complete telemetry story and centralize all of that off away from your environment so that you can do queries and alarms. And this builds up a data warehouse of information so that you always know what your application is doing. Logs are not sufficient. Application Insights automatically gives you a lot of telemetry just by hooking it up. You can see here that it sniffed out that a database query was happening because it understands .NET, it understands Entity Framework, it understands SQL Server. You actually get a lot of automatic telemetry just by hooking it up. Then finally, we talked about annotating the release. This is where that comes in handy. This is the Azure Portal performance pane of Application Insights. If your performance starts to go sideways or something starts to go sideways, it's great to be able to come back and say, when did we do those deployments? Oh, our metrics started going sideways right after this deployment. If you click on that release marker, then you get a link right back to Azure Pipelines for the project and the release that created that. So you have full traceability forward and backward. And before I talk about a few case studies here, I want to take the questions that I wasn't able to work in directly as we kind of wrap up here. And so the question is, there's a big system, say 40 applications. Each of the 40 can be deployed separately for a no downtime deployment, but are they still part of the same application system? Do you need different pipelines for each piece? Currently, we have different Octopus projects for each piece, and they build each separately, but I'm migrating to one build. Thanks. Okay, so this is the software system organization. Every independently deployed application needs its own DevOps pipeline. And again, it starts from the architectural decision of the Git repository. If you have, let's say you have 2 developers on your team and you have 1 Git repository and you have just a big application. You could have a massive application with 40 deployable processes, but because you've made the architectural decision to group all of those deployed processes as one logical application, then that's your decision and you put it in one Git repository. Someone else could make the same decision that I want on the other extreme, that I want every single one of those deployed processes to be its own logical application and version and deploy independently. And then we'll do some higher level orchestration and create the concept of a software system. Not every application is part of a software system. A lot of applications are their own software system, but especially when going for the microservices style, you're creating a situation where your application unit is smaller, and so you need to create the software system level of organization that's above it. And the building blocks of that are Git repositories. You're going to have one Git repository for every application, and then you're probably going to have another Git repository that is the system shell, or it may be just some configuration management files, because there's always going to be some code, some files, even if it's just configuration, that belongs to the software system that you can't say is owned by any one particular application. But each of those applications needs its own pipeline. And even if the software system was going to bundle everything up and have a single deployment event, every independent application, every independent Git repository still needs a pipeline, even if that pipeline does not go all the way to a production environment. Even if that pipeline only goes to the test automation environment and a manual test environment. And then maybe to get to production, the system level pipeline bundles the release candidates of all the individual ones, and then has a deployment event, a bundled deployment event to a staging or a manual test environment at the system level, and then a production environment. You still need the test automation environment at the system level, because you still need to derive some fully integrated full system tests that'll make sure that the whole system is stable. So I hope that helps. That is a pretty common question with larger software organizations. We've helped out a number of clients factor in the multi-level DevOps environment, because it can be a little bit tricky. But we've helped out so many development companies who are doing outsourced development projects for their clients. We've helped out so many companies that have internal development teams that are new and old. There are a lot of new companies that are getting into development. Our goal is for you and your team to be self-sufficient, so you need to outsource less. We're like the anti-outsourcer. So if you're looking for a software architecture company or a company to help you up-level your internal capability or get you over a hump, or if you've spent weeks and weeks trying to get something working, and you'd really just like it working tomorrow, give us a call. All right. So next steps. We have some very common options related to Octopus Deploy on the bottom here. The Jumpstart, just setting up Octopus Deploy the right way for the first time. If you have an existing setup, we do tons of inspections so that we can show you what needs to be adjusted to design it. If you're modernizing an existing application for automated deployments, that's pretty common too. Or if you just need a second pair of eyes on the organizations, just some advice, we're happy to help there. All right, I'll put the contact information up on the screen, and I believe all of the questions have been answered, but send me an email or give me a call or find me on Twitter, and until next time, keep shipping.